Good morning. If you're receiving this video, that means you are absent and need to complete the sound waves activities that we did. So, basically, what we're looking at is we've learned that sound now is a longitudinal wave, right? And something is going to compress those molecules and create these pulses of compressed air and rarefied air. And so, what we did in this lab is we're just kind of looking at how can a sound wave transfer energy. Okay, so we did a couple of simple activities. I'm going to do my best to kind of show you on here and walk you through those questions. So the first one, just make sure you have that document open. And you're following along as we do these, and then that can help you answer these questions. Okay, so the first one, what we wanted to do, let's see if we can see this here, is we wanted to see what happens as we place a tuning fork that's vibrating in water. And really what we want to look at is, okay, as we put something into this water, what happens to the waves? What do we see? What direction do they move? Where do they start? What happens when they reach the end, right? So tuning fork, right? Here, I got my mallet to strike it. So see if you guys can see this, hopefully. Whoa, so neat. Okay. So if you could see that, what we hopefully saw was that as we place the tuning fork down into the water, obviously the tuning fork is vibrating, right? So that's how it is compressing compressing the air and creating these sound waves. And as we touched it to the water, right, it's going to create a disturbance. So hopefully you saw those waves originated from the tuning fork and went away from the tuning fork, right? So the question talks about, okay, what did we see with the waves? What direction did they move in relation to the tuning fork? Okay, so they moved away. And then as they reached the edge, what we saw is they reflected back in, right? So reflection, different from refraction. Reflection means they're going to bounce off and go back the other direction, right? So they reflected off the end, okay? So that's the first station. So you can pause this if you want to type in some answers there. Just do your best on that, okay? Now, next station. So this one is basically we want to see, okay, how can these sound waves transfer energy? Okay, so what we're looking at here is we have a cup, and on the top of the cup, I don't know if you can see that real well, it's not just dirty, it's a bunch of salt. Okay, and then we got a piece of plastic on the top. And we're going to see what happens. So I'm going to hit the tuning fork and we're going to put it close to the salt and we're going to see what happens. Okay, so there we go. Oh, what a beautiful sound. Wow. Wow. Let's try that again. Let's see if we can get it to where you guys can actually see it a little bit better. A bunch of booger pickers got everything wet. They like to ruin anything that's fun. There we go. Whoa. So see out there, it's kind of quiet, but it's still about the same distance, and then really speeds up. Okay. So as I rotated that tuning fork, so I never touched so one thing we want to look at, one question it has is, I never touched the plastic or I never touched the cup with the tuning fork, yet the salt is still moving. So we got to think about, okay, so the tuning fork is moving. What is that pushing on, right? So we're thinking, okay, well, it's pushing on something. It's pushing on the air around us, okay? Then that air goes, and that's got to be pushing on something. So that air is going to be pushing on the top of this plastic, right? Causing the plastic to vibrate. As the plastic vibrates, then we get to see the salt start to move, okay? So that's kind of the progression of transferring that energy. How is it being transferred now? And then if you notice, when I first put the tuning fork up here like this, right? The salt was moving quite a bit. Then as I kind of moved like this a little bit, it's a little bit less. And then as I turned sideways here, again, it got a little bit stronger, and then a little bit less and a little bit stronger. So it asks you, how is this connected when we look at terms of like amplification or interference? So if we think amplify means it's going to make things bigger, right? More energy. So obviously, okay, I think if we have more energy, we probably are going to see more movement. If we have interference, right, those waves are going to kind of get canceled out by each other and make them smaller. So we're going to see a little bit less movement, right? So kind of work that into your answer for that. Okay. Now, the third one talks about ping pong ball and using the tuning fork with that. So what we're going to do is I'm going to hit the tuning fork, and then we're just going to push it really, really close, and then just barely touch that ping pong ball. We're going to see what happens. Whoa. Whoa, let's watch again. Right. So this one, right, it's kind of cool. But when we think about it, when we really break it down, it's kind of simple, right? So how does the tuning fork work? You hit a side, right? And these ends start to vibrate. And vibrate's just a fancy word for moving back and forth. Okay. So when we think about what type of energy they have, think about that. If it's energy of motion or movement, it's kinetic energy, right? So it's basically just it has mass, it has movement, it's got some momentum, it's transferring that kinetic energy into the ping pong ball. Okay, so that's the third one. Now, finally, the last one. Okay, last one just has you watch that video. Some of you guys have probably seen that already, but it's kind of weird. So the question's asking, like, okay, how do we get, or why does the salt collect in those very specific spots? Okay. So just on the first one, I want you to just make your best guess, right? Like why? Like if you saw that happening and didn't know anything about it, like why, right? So then as we kind of start looking through it, what's making the salt move? Obviously, the plate has to be moving. Okay. Something the plate is moving, which is causing the salt to move. So then we can kind of think, okay, well, the spots where the salt is being pushed off the most is probably moving the most, right? That makes sense. And the spots where the salt is collecting isn't really moving. Okay. So how does that happen? So take a guess on that. Then it says, okay, Google standing wave labeled. Okay. So when you Google that, go ahead and do that real quick. Pause the video. But when you do that, when we say standing wave, that's exactly like we had in our spring lab, if you were here for that. So what that means is you have a fixed spring here, right? Or we had our spring, a fixed point here, and we created this wave, right? So we'll just look at one single wave. Now, instead of this transferring and looking like it's moving from left to right, what a standing wave does is it looks like it's just kind of moving up and down. So it kind of looks like these are just switching places. So as it changes position, kind of looks like that. Okay, so it looks like it's just kind of going back and forth, right? So as we think about this, and you can Google videos about standing waves. This part, right? If we had a piece of salt right here, and then it dropped down right here, and then it shot back up right to there, right? That's a lot of movement, right? So we can imagine what's going to happen to that piece of salt. It's going to bounce off, right? And it's going to go to another spot. Same thing over here. That piece of salt is here, and it's moving down and then back up, and it's going to get shot off. But what do we notice? What if we have something right here, right? Does it look like there's a lot of motion here, right? And so when we Googled that labeled image, we should have found that is called the node, right? So at the nodes is kind of this still position in between a crest and a trough, right? Where we don't really have a lot of movement, okay? So in that video, why that happens is we have a bunch of intersecting waves, and then we get these weird spots where we have wave nodes that also intersect. And that's where that salt is going to actually collect. Okay, so hopefully this is helpful. Use that to complete the video. Submit it on Google Classroom. You can fill everything in on that Google Doc. That's why I gave you that copy. So, all right, see you guys soon. Bye.